Hi guys, I hope you are doing well. This is very amazing session to building a sentence similarity with Python using different approaches like TF-IDF, sentence transformer, and Word2Vectors. So guys, sentence similarity technique can be highly useful in large language models, LLMs, for learning, and it will help in user experience in content recommendation, semantic search, etc. All right. And here, guys, we have built this sentence similarity checker with the help of Streamlit and Python supportive packages. And guys, here you can enter your sentences and your paragraph, and you can check your similarities with the help of these three techniques. And here you will see the different score based on their similarity type. So guys, let's build this approach from scratch. So guys, I have launched the VS Code, and here I am going to create a file which is app.py. And first of all, I need to import some necessary library in order to build sentence similarity checker, right? So guys, first of all, I am going to import Streamlit as st, and I need a sentence transformer, right? So sentence transformer, and from this, I am going to import sentence transformer. From the Scikit-Learn, I need to import the TF-IDF vectorizer. So from Scikit-Learn dot features extraction, and from the text, I need to import TF-IDF vectorizer. All right. So we will be perform these kind of similarity with the help of cosine. Okay. So from SciPy and is a distance, and let me import cosine similarity, right? And guys, to perform the Word2 vector, we need to import genism dot models, and from that I'm going to import keyword vectors. All right, and I need to import the another library as numpy. So these are the basic library we need to import in order to build the TF-IDF, BERT, and Word2 vectors. All right, so first of all, I am going to create a function that will be compute the similarity between two sentences. Okay, so simple compute similarity. And guys, within this function, I need sentence 1 and sentence 2 and the similarity type. What kind of similarity type I want to apply. All right. So guys, in this function, I will be perform TF-IDF, word, and Word2 vectors. All right. So first of all, let's understand what does these three techniques. So guys, first of all, TF-IDF. TF means term frequency and IDF means inverse document frequency. Okay. So TF-IDF vectors are used to information in retrieval task. For an example, if you want to keyword extraction, or maybe sometime as a features in machine learning model for text classification or clustering. So this TF measure how often a word appears in the documents. Okay. And if a word show up a lot in the document, so TF is high for that word in the documents. All right. So this idea is very simple. If a word appears many times in that particular documents, so it's probably important for understanding that document, right? And similarly, let's say if we are using inverse document frequency, so IDF, right, which is inverse document frequency, measure how important a word is across many documents. All right. So you can see here words like if you are using and the or maybe some other words. So these kind of words are almost present in every document. And these are not special for us. Okay. But whereas the word that appears only in few document like pangolin or maybe algorithm. So these are the most unique or most popular word, right? Okay. In order to get a higher ID score. All right. So for an example, if your word is more weightage, so you will have higher IDF score. All right. And the second technique we will be used, which is BERT, bidirectional encoder representation from transformer. So guys, BERT is nothing, is a transformer based model which is designed by the Google. Okay. And this BERT is basically used for various NLP tasks such as questioning, answering, semantic analysis, and the name entity recognition, and more. Okay. Where understanding the context of a word is a very crucial, right? So here, as I just mentioned, BERT is a transformer based approach. And the architecture in the BERT is based on the transformer architecture, right? Specifically designed to handle the sequential data like sentences or documents. And BERT embedding capture rich and contextual information about the words and their relationship within a sentence or documents. All right, guys. And again, BERT and TF-IDF are fundamentally different approaches in realm of natural language processing. So guys, please keep in mind, TF-IDF does not have a specific architecture like BERT. BERT basically from the transformer, okay? And whereas TF-IDF is a statistical measure used to evaluate how important a word is to a document in the collection or a big corpus. Whereas BERT embedding are a specific application for the transformer architecture and which is tailored for natural language understanding tasks. All right. Or you can say that in summary, BERT and TF-IDF represent two different approaches in NLP. Whereas BERT focus on capturing contextual word representation using deep learning technique, and while TF-IDF provide a statistical measure to represent the importance of a word in the document based on their frequency. Okay, you need to remember based on their frequency in TF-IDF. All right. And similarly, if I'm talking about Word2Vectors, and guys, Word2Vector is a group of continuous bag of word, right? CBOW and skipgram introduced by the Google that generate a word embedding by training a shallow neural network to predict word given their context or vice versa. So these are the dense vector representation of a words, unlike sparse representation like TF-IDF. Each word is mapped to the fixed length of vector of real numbers. So guys, Word2Vectors are dense vector representation of the words, right? If I'm talking about TF-IDF, so the nature of representation of TF-IDF provides sparse representation, which means high dimension vectors with many zeros. And similarly, if I'm talking about the BERT embedding, those embedding are on dense vector, which is low dimensional with continuous data. All right. And Word2Vector we can use with the help of Janus, a very popular Python library for training and using Word2Vector embedding. So guys, let's build this kind of functionality from scratch. Now, if you are using a similarity type, so guys, if the similarity type equal to TF-IDF, and here, let me use here TF vectorizer. All right. And now TF-IDF matrix, I'm going to generate with the help of fit transform. And here I'm going to supply my list, which is sentence 1 and the sentence 2. Easy. And here I am going to check the similarity equal to 1 minus cosine similarity, right? And here I am using TF-IDF matrix and I'm supplying here the 0 for the first sentence and I'm going to convert into the array. And similarly, guys, I am going to accessing the second sentence and the same thing I am going to convert into the array. All right. So guys, what is the meaning of this line? So first of all, I am going to initialize the TF-IDF vector and here I am using a matrix, okay, where I'm going to fit the vectorize on the two sentences and transform them into TF-IDF vector. And here I am using TF-IDF matrix 0 and here I am using 1. So what is the meaning of it? So here I am going to access the sentence 1 and sentence 2 respectively, and I am going to convert the sparse TF-IDF vector into the dense NumPy array with the help of 2 array. All right, is a very simple. And here I am using 1 minus cosine distance, which convert the cosine distance to cosine similarity. All right. And similarly, if I'm using here aleph equal to sentence transformer. All right. And now again, I'm using a different model, which I have imported already. And guys, here I am using this particular model. All right. And similarly, embeddings equal to model.encode. And here I'm passing sentence 1. And similarly, I'm passing for the sentence 2. All right. And for the third one, I am using again the similarity type for Word2Vector. Okay, Word2Vector. And here I'm using model equal to Okay, so this is key vectors dot load. So this is load Word2Vector format, guys. And here you need to download a one file. Let me show you. So guys, here you need to download Google News vectors negative. This particular file you need to download. Okay, so simple. You can go any link, right? So let me click on Kaggle. So you can log in Kaggle by your email ID and you can download this particular file. Okay, it's a big file up to 3 GB. So guys, I have already downloaded and I have imported this particular file successfully in my current working directory. And for your information, this particular Google News vector negative 300.pin, right, which is contain a pre-trained word embedding, okay, and generated using the Word2Vector algorithm on the large corpus of Google News articles, okay. And guys, it will contain lot of information, as I just mentioned, 300 dimensions space, and we have millions of words, right? And guys, here I'm using binary equal to true. And after that, I'm using here also embeddings equal to. So guys, let me explain this. Here I'm using outer comprehensions where I'm going to apply the loop on sentence 1 and sentence 2. And here I am going to split the each sentence into the words, right? And each word I want to check into the Word2Vector model's vocabulary. And similarly here, I am using np.zeros model.vector size. What is the meaning of it? So if none of the words in the sentence are found in the models, right? Or you can say that resulting in an empty list. So this particular part ensure that a zero vector of that appropriate size. All right. So in case that particular word is found, that's fine. I will be compute the mean of the word vector of each sentence, okay, along with the zeroth axis. Okay. So let me write here, yeah, zeroth axis. And this particular result in a single vector representing the average embedding of all the words in the sentences. All right. And similarly, I am going to check the similarity equal to 1 minus cosine of embedding of 0, comma, embeddings of 1. Okay. And else, okay, if I am not using TF-IDF or sentence transformer or Word2Vectors, so I am going to raise a value error. Okay, so simple invalid similarity. All right. And after that, I am going to return similarity. And now guys, I am going to build a Streamlit application. So simple st.title and here sentence similarity checker. All right. And now I am going to user inputs. So user input means, first of all, I am using here the sentence 1 equal to. So user can insert or can provide their sentence or the paragraph. Enter the first sentence. And similarly, I am using for the second sentence. Okay. And now guys, I am giving some option to the user so they can check the similarity types. So option to select. So simple similarity types equal to st dot multi select. Okay. And here you can choose TF-IDF, comma, I am passing sentence transformer, and here I am using Word2Vector. Interesting. Now let me close this bracket. Okay. And now I am going to create a brand new button where I can compute the similarity. So if st dot button, let me write the button name similarity. And guys, simple. If you are passing the sentence 1 and the sentence 2. Okay. And here if TF-IDF in similarity types, then I am using TF-IDF similarity equal to, now here I am going to calling my function. So compute similarity, and here I am passing my sentence 1 and sentence 2. Okay. And here the type is TF-IDF. All right. nst.write TF-IDF similarity simple. All right. And guys, similarly, let me copy these 3 lines. Copy and paste. And if I am using here the sentence transformer, so simple sentence transformer in the similarity types, and the same thing here I am going to use. All right. And the last we are using for the Word2Vectors. Simple Word2Vector. So we can check this. Yes, Word2Vectors. All right. And now Word2Vector. Same thing. And here, guys, Word2Vectors. Simple concept. If you are not using any particular similarity type, so st.write, please. So guys, if you are not providing the both the sentences, so I am going to warn to the user. So please enter both sentences. Okay, simple, right? Very neat and clean. So simple, I have created the compute similarity, and whatever the input you are passing, based on that, I am going to check that particular similarity. All right, so let me save this and now let me run this. So guys, let me select here the command prompt and simple Streamlit run app.py. And here I'm using server port, a specific server port, right? So guys, here you can enter your statement. Let's say the sun is shining brightly today, and here it is a sunny day. Okay, interesting. Now I am going to choose the TF-IDF, sentence transformer, and Word2Vectors. All right, now let me run this. So guys, it is giving me a 0 score for TF-IDF and the same score for the BERT, which is sentence transform similarity. Okay, let me check here. So here TF-IDF, and here we need to use sentence transformer. Okay, which one? And similarly, here we need to use Word2Vectors. And guys, apart from this, let's say we haven't defined the full name with extension, so it should be .bin. All right, now let me save this and let me rerun. Now let me click on compute similarity. So TF-IDF similarity is 0. Okay, and now I am going to perform sentence transformer. So guys, we are getting an error, unbound local error, cannot access local variable similarity where it is not associated with its value. Okay, so in the sentence transformer, let me check. Okay, we are not returning, right? So let me copy the same line of statement and let me paste. All right, now let me save and let me rerun. So guys, this will take long time because it is processing your long file. That long file size is more than 3 GB. So guys, you can see here the TF-IDF similarity is a 0. Okay. And you can see the performance of BERT, right? Sentence transform similarity, where we have 0.89. And the Word2Vec similarity is 0.42. And please keep in mind, here we are using a very large file. That's why this is working very slow. Okay, so I am going to remove this. And now I'm going to pass some different items. So for an example, let's say the project deadline is approaching soon. And similarly, let me change this particular statement. Let's say we need to finish the project before the deadline. All right, now let me run this. So here, guys, 0.33. And now for the sentence transformer, it is 0.75, right? Which is amazing. And now similarly, let me change another statement. Let's say he loves reading books on history, and history books are his favorite. All right, now let me run this. So TF-IDF score is 0.22 and the sentence transformer similarity is 0.84. Okay. And the last statement, let me use here. Let's say C is preparing a presentation for the meeting. Okay. And C is working on meeting presentation. All right. Now let me compute. So guys, 0.45, right? And for the sentence transformer is a 0.90, right? Which is very amazing. All right. So guys, you can see here, I am using a very neat and clean concept. So I will be provide this particular script in your description. So you can check and you can play with this with your statement and with your paragraph. So guys, I hope you enjoy in the session and you have learned something new. And in case if you are facing any issue or difficulties or maybe any thought from your side, please let me know in the comment box. And for now, thanks for watching and have a great day.